Hello everyone. Today, we will start learning about the determination of the YD connection group number for three-phase transformers. In this lesson, we will mainly cover the following two aspects. 1. Mastering the determination of the YD connection group number for forward delta connections. 2. Mastering the determination of the YD connection group number for reserved delta connections. First, let's analyze the determination of the YD connection group number for forward delta connections. When determining the connection group of transformers, we usually use electromotive force to create a phasor diagram. First, draw the phasor diagram for the high voltage side. According to the symmetry of the power source electromotive force, first, draw an equilateral triangle. Find the centroid of the equilateral triangle. The lines from the centroid to the three vertices of the triangle represent the corresponding phase electromotive force. The three sides of the equilateral triangle represent the line electromotive force. This geometric relationship exactly fits the star connection circuit, where the line electromotive force equals the phase electromotive force multiplied by the square root of 3. The phase electromotive force directions all point to the centroid. The line electromotive force directions follow the alphabetical order, such as EAB pointing from point A to point B. Remember, as long as the high voltage side is star connected, this equilateral triangle remains fixed. To correspond with the clock method, usually place the AB side of the triangle vertically. This represents the minute hand of the clock. After completing the phasor diagram for the high voltage side, proceed with the low voltage side phasor diagram. Since the low voltage side is forward delta connected, forward delta connection means the end of phase A is connected to the start of phase B. The end of phase B is connected to the start of phase C, and the end of phase C is connected to the start of phase A. When the low voltage side is delta connected, the two coils aligned vertically on the high and low voltage sides have their phase electromotive forces either in phase or put out of phase. The criteria for judgment are: 1. If the starting terminals are like terminals, then the high and low voltage side phase electromotive forces are in phase. 2. If the starting terminals are unlike terminals, then the high and low voltage side phase electromotive forces are out of phase. When determining the connection group using a phasor diagram, the main task is to determine the phase difference between the high voltage side line electromotive force EAB and the low voltage side line electromotive force EAB. The phase electromotive force of the delta connection equals the phase electromotive force. According to the structure in the diagram, the corresponding relationship is that the line electromotive force EAB equals the phase electromotive force EAX of phase A. The line electromotive force EBC equals the phase electromotive force EBY of phase B, and the line electromotive force ECA equals the phase electromotive force ECZ of phase C. When the low voltage side is delta connected, to draw the phasor diagram of the line electromotive force EAB, just draw the phasor of phase A on the low voltage side. This can determine the connection group. In the diagram, phase A on the low voltage side is in phase with phase A on the high voltage side. At this point, just draw a parallel line from point A in direction of phase A on the high voltage side, and ensure the direction is consistent. Then, point B must lie on the phase electromotive force of phase A on the high voltage side, as shown by the white line segment in the phasor diagram. From the phasor diagram, we see that the angle between the line electromotive force EAB and the low voltage side line electromotive force EAB is 30 degrees. At this point, the connection group of the three-phase transformer can be determined as YD1. Generally, the low voltage side should create a complete triangle, which can be drawn directly in a clockwise direction. As a phase sequence typically refers to a positive sequence, thus, the three vertices A, B, and C of the triangle formed by the line electromotive forces must be arranged in a clockwise direction. As shown by the white lines in the diagrams above, on the previous basis, if the high voltage winding remains unchanged and the low voltage windings A, B, and C each move one phase to the right, as shown in the right diagram, then the low voltage side phase C aligns with the high voltage side phase A on the same core column. Phase A of the low voltage side aligns with phase B of the high voltage side on the same core column, and phase B of the low voltage side aligns with phase C of the high voltage side on the same core column. Since the primary and secondary side starting terminals are like terminals, the phase electromotive forces on the same core column for the high and low voltage sides are in phase. The phasor diagram for the high voltage side remains unchanged, since the line electromotive force EAB on the low voltage side equals the phase electromotive force of phase A, and is in phase with the phase electromotive force of phase B on the high voltage side. Just draw a parallel line from point A in the direction of phase B on the high voltage side, and ensure the direction is consistent. From the phasor diagram, the angle between the line electromotive force EAB and the low voltage side line electromotive force EAB is 150 degrees, which determines the connection group of the three-phase transformer as YD5, as shown by the white lines in the diagram. Similarly, complete the triangle on the low voltage side, keeping the high voltage winding unchanged. Continue moving the low voltage windings A, B, and C one phase to the right on the previous basis. As shown in the right diagram, at this point, phase B of the low voltage side aligns with phase A of the high voltage side on the same core column. Phase C of the low voltage side aligns with phase B of the high voltage side on the same core column, and phase A of the low voltage side aligns with phase C of the high voltage side on the same core column, with the primary and secondary side starting terminals being like terminals. The phasor diagram for the high voltage side remains unchanged. The relationship between the high and low voltage sides is that the line electromotive force AB on the low voltage side equals the phase electromotive force of phase A, and is in phase with the phase electromotive force of phase C on the high voltage side. Therefore, draw a parallel line from point A in the direction of phase C on the high voltage side, aligning with phase C. This represents the phasor of the line electromotive force AB on the low voltage side. From the phasor diagram, the angle between the line electromotive force EAB on the high voltage side and the line electromotive force EAB on the low voltage side is 270 degrees, indicating that the connection group number for the three-phase transformer is YD9. Similarly, complete the triangle as shown in white. Next, let's look at the determination of the reverse delta connection on the low voltage side. The reverse delta connection means the start of phase A is connected to the end of phase B. The start of phase B is connected to the end of phase C, and the start of phase C is connected to the end of phase A. The phasor diagram for the high voltage side remains unchanged. From the wiring diagram, we can see that the relationship between the line electromotive force and the phase electromotive force on the low voltage side is as follows. Line electromotive force EAB equals the negative phase electromotive force of phase B, which is EBY. Line electromotive force EBC equals ECB, and line electromotive force ECA equals the negative phase electromotive force of phase A. Therefore, to draw the phasor of the phase electromotive force EAB on the low voltage side, the phase electromotive force of phase B on the low voltage side should be drawn and inverted. Since phase B on the low voltage side is in phase with phase C on the high voltage side, just draw a parallel line from point A in the direction of phase C on the high voltage side, but inverted, representing the phasor of the high electromotive force EAB on the low voltage side, as shown in white in the diagram. From the phasor diagram, the angle between EAB on the high voltage side and EAB on the low voltage side is 330 degrees, indicating the connection group number for the three-phase transformer is YD11. Similarly, directly draw the equilateral triangle ABC for the line electromotive force on the low voltage side in a clockwise direction. Completing the phasor diagram for the low voltage side, it is obvious that the vertex C of the triangle on the low voltage side must be above the phase electromotive force, point A, on the high voltage side. Keeping the high voltage winding unchanged, move the low voltage windings A, B, and C one phase to the right on the previous basis, as shown in the right diagram. At this point, phase C on the low voltage side aligns with phase A on the high voltage side on the same core coulomb. Phase A on the low voltage side aligns with phase B on the high voltage side on the same core coulomb, and phase B on the low voltage side aligns with phase C on the high voltage side on the side core coulomb. The phasor diagram for the high voltage side remains unchanged. The relationship between the line electromotive force and the phase electromotive force on the low voltage side is that EAB equals EBY, and the phase electromotive force of phase B on the low voltage side is in phase with the phase electromotive force of phase C on the high voltage side. Therefore, draw a parallel line from the point A in the direction of phase C on the high voltage side, but inverted. From the phasor diagram, The angle between the line electromotive force EAB on the high voltage side and the line electromotive force EAB on the low voltage side is 90 degrees, indicating the connection group number is YD3, as shown in white in the diagram. To complete the triangle on the low voltage side, follow the clockwise direction. Then, point C must be on the small AB segment. On the previous basis, move the low voltage windings A, B, and C one phase to the right again, as shown in the right diagram. At this point, phase B on the low voltage side aligns with phase A on the high voltage side on the same core column. Phase C on the low voltage side aligns with phase B on the high voltage side on the same core column. And phase A on the low voltage side aligns with phase C on the high voltage side on the same core column. The phasor diagram for the high voltage side remains unchanged. The relationship between the line electromotive force and the phase electromotive force on the low voltage side is that EAB equals EBY, and the phase electromotive force of phase B on the low voltage side is in phase with the phase electromotive force of phase A on the high voltage side. Therefore, draw a parallel line from point A in the direction of phase A on the high voltage side, but inverted from the phasor diagram. The angle between the line electromotive force EAB on the high voltage side and the line electromotive force EAB on the low voltage side is 210 degrees, indicating the connection group number is YD7. As shown in white in the diagram, from the previous analysis, we can draw the conclusion. When the low voltage side is forward delta connected, there is always the relationship that the line electromotive force EAB equals the phase electromotive force EAX. When the low voltage side adopts the reserve delta connection, there is always the relationship that the line electromotive force EAB equals the negative phase electromotive force of phase B. When the high and low voltage sides of the transformer are star delta connected, that is, the connection methods are different, the connection group number can only be 1, 3, 5, 7, 9, 11, which are all odd numbers. The phase level of the high voltage side remains unchanged. When the phase level of the low voltage side moves one phase to the right, the connection group number increases by 4. In this lesson, we mainly introduced the determination of the connection group for three-phase transformers when star delta connected, whether it is forward delta or reserve delta. The determination method is the same. First, use the wiring diagram to find the relationship between the line electromotive force AB on the low voltage side and their corresponding phase electromotive force. At the same time, find the relationship between the corresponding phase electromotive forces on the high and low voltage sides. Once this relationship is clear, drawing the phasor diagram becomes simple. Okay, that's all for this lesson. Goodbye.